Again, my name is Charlene. I am the H2 math tutor for OVERMUGGED, and I've been sort of teaching H2 math, A-level math for about 5 to 6 years now. And what we do at OVERMUGGED is we give private and group tuition. We also do crash courses nearer to the exam dates, right? So like your prelims, your A-levels and stuff. And this slot, this Sunday 1 to 3 p.m. slot is reserved for J1 H2 math group tuition. It will be online. So if you're interested, at the end of the session, I'll be sending out a form for you to sign up for the actual tuition class. Yeah. So before we begin, because for many of you, this would be like the first official, I guess, H2 math tuition lesson that you have, right, for the year. What I want to share is an overview of what's coming your way for H2 math. You can see here, sorry, my handwriting is a bit messy, not the best, but yeah, okay. What you guys will be expecting, or what you can expect for year 1 is everything to do with pure math. So H2 math is split into 2 parts, right? We have pure math, and then we have statistics. Okay, so statistics is, I think, slightly easier to most people, and you'll be covering that in your year 2, nearer to A-levels. In year 1, what you'll cover, right, is all the stuff in red. So you can see over here, right, we have your vectors, functions, graphing techniques. We have your APGP, so arithmetic and geometric progression, which is what we'll be covering in today's session. Most of your schools will be starting with this topic first. And then we have summation of series, okay? We have your differentiation and differentiation applications, integration and integration applications. So for here, right, differentiation and integration, most of you will have covered this in A math in secondary school as well. So it's not that daunting, to be honest, but the tricky part is the applications part, much more complicated in JC. In integration applications, I guess you guys will have learned area under the curve, right? This time you will learn like volume of like rotation about the axis to find like the volume of that solid form when the curve is rotated. Yeah, so it's a bit more complicated, but no worries, still very, very manageable. Okay. We also have your Maclaurin series, integrate, and then we have differential equations, and then we have our complex numbers as well. So all this is pure math, right? You won't be covering everything in J1, but you know, you'll be covering maybe about 80% of the pure math part in A1, J1, and then stuff like complex numbers, differential equations, right? Maybe even Maclaurin series. These are the topics that your schools will likely cover in J2, together with the rest of the syllabus, which is the statistics part, the one in blue, right? And this statistics part is really like, I guess in secondary school, you guys will have learned probability. It's stuff like that, right? Like probability, your permutations and combinations, binomial distribution, normal distribution, like these are things maybe you have covered in secondary school as well. And then we have the remaining as well, like sampling, hypotesting, and correlation and regression. So you can see, right, this is like a lot of topics to cover in just 2 years, and it's not, say, super easy topics. So I think one piece of advice I wanted to give everyone is also like for JC, right, it's very important that you remain consistent, right? I feel like in O-levels, it's still like, okay, maybe the last few months you chiong, right? Like you study very hard for the last few months, it's still kind of acceptable. You can probably still get an A out of it. But like for JC, I would say it's much tougher. I'm not 100% sure whether, I mean, there are people who can do that last 3 months sprint, right, and just chiong, but you must take note, like keep in mind that it's not just H2 math, right? You have like your other subjects as well. In general, I feel like for me personally, JC was like quite a stressful time of my life. And looking back, like I wish I was a lot more consistent with my work, with, you know, my learning. And I think that's just a piece of advice that I can give you. Yeah. Okay, so in JC, you also have 2 papers. Okay, just giving you an overview. You have 2 papers, paper 1 and paper 2. Okay, so we have paper 1. Which is just 100% pure math. Okay, And paper 1 is 3 hours. Paper 2 is also 3 hours. Okay, but it is 40% stats. Sorry, 40% pure math. What am I thinking? 40% pure math, and then it will be 60% statistics. Each are 100 marks. Okay, so if you go and calculate, right, okay, what does this mean? It actually means that for each mark, right, okay, 1 mark, you have 1.8 minutes to complete that mark, for that mark. Of course, some chapters will take longer than others. Yeah, it really depends, but in other words, in math especially, it is important for you to not just get the question right? Like obviously you want to get the question right, but for you to be accurate, have speed, be able to do things quick also, and you are not going to be able to do that without, of course, practice. Okay. So revision strategies for you, right? Number 1, and throughout my lessons, right, I will actually be, of course, how we'll be doing it is I will take you through the notes, right, the actual topic of the lesson, and then you will have practice questions that I will expect you to be able to do for homework, right? We will be doing mainly everything via Google Classroom, okay, because it's an online class. But sometimes here and there, every few weeks or so, I will also be doing like tests, mini tests, like maybe just 1 or 2 questions for you to test your understanding. And that's a super key revision strategy for JC in general, right? For you to not just practice questions, but quiz and time yourself, because you need to make sure that within that exam 3 hours, right, you are able to complete everything. You don't just want like quality, you want quantity as well, right? You want to be able to complete all the questions. So you need both, okay? Okay, so other important tips. Important for you guys to get your foundational topics right. That means like all the J1 topics, right now, build a strong base, right? For each topic also build a strong foundation before like you think about like, oh, how do I apply this and stuff, okay? Clarify your doubts early, which is why if you have any questions throughout today's session, please just voice it out, right? Don't, like keep anything inside, yeah, and don't let your doubts linger, and then be very consistent. Yeah, so that's the tips I can give you. Okay, so let's jump straight in. We'll be doing AP GP today. So if most of you would turn to your notes, right? Okay, we're going to start with this topic. Okay. So before we dive into AP GP, what arithmetic and geometric progressions are, right? Okay, we need to talk about sequences and series first. So I think most of you, like, okay, if I tell you sequence, like as a word you will understand, series as a word you will also understand. I think the tricky part is like, how do you apply it in math, right? Okay, because arithmetic and geometric progressions are actually a special kind of sequence and series. Later on you'll see. Okay, so let's start with the basics. Again, always go back to your foundational, like first principles, right? In math, it's very important to build that strong foundation before you think about like, okay, how do I do this question, etc. Okay, so really when I'm going through the topics, try to understand before you think too much, right? Truly understand and then move on. So if you have any doubts, any questions, feel free to put them in the chat. I have it open on my screen at all times. Okay, so sequences and series. Okay, let's start with what a sequence is. So a sequence, okay, is a set of numbers in a defined order. It's arranged in a defined order. Okay, that means basically what is it, right? It is a list. A set of numbers is actually a list, right? Okay, a set of numbers is actually a list. Okay, so it's a list that is arranged, right, in a defined order. In other words, right, it is not random. You cannot just plug, right, a bunch of random numbers, right, and call it a sequence. Okay, it is a list of numbers, but there is an order to it. So for instance, you see over here, right, 5, 8, 11, right? What is the order? You always plus 3. So it's very, very methodological, right? And below you'll see other examples of sequences, okay? And each number in the sequence, so for instance, number 5, number 8, number 11, right? Each number in the sequence is called the term of the sequence, right? And they are usually denoted as such. So for instance, for this sequence over here, our 5, 8, 11, right? 5 will be our first term, which we denote as U1. 8 will be our second term, which we'll denote as U2, okay? So in this case, U1 will be your 5, U2 will be your 8, so on and so forth, right? Okay, so on and so forth, okay? A sequence, right, okay, can have finite or infinite numbers, okay? What does it mean? Finite means that it stops somewhere, right? There is an end to it, okay? Infinite means infinity, right? It means that it goes on forever and ever and ever, okay? So you can have a sequence that maybe ends just at like, for instance, maybe it ends only at 14. So there's only 4 terms of the sequence. But you can also have a sequence that goes on forever and ever and ever, right? It just dot, 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 right? It will go on forever, okay? So now let's fill in this table together. You would have it, I guess, in your notes if you manage to print it out. Okay, let's see, right? For the first row, right, UN, okay, the general term is n squared, okay? So n, right, we have 1 all the way until 12. This would be a finite sequence because there is an n, right? It ends at n equals to 12, okay? What would U6 be? So to find out what U6 will be, right, all I have to do is I plug in U6 will be 6 square. I plug in my n, right? My n is over here, 6. I plug in 6 over here, and I should get 36. So U6 in this case will be 36, okay? The sequence, right, will be, okay, so if I plug in 1 over here, okay, I plug in 1, I will just get 1. I plug in 2, I'll get 4. Plug in 3, I'll get 9. Plug in 4, I'll get 16, all the way until my n, right, will be when n is 12, and my U12 will actually be 12 square, which is 144. So I'll write all the way until 144. And this will represent my sequence. Is everyone clear so far? If you're clear, do give me a thumbs up, right? All right. Great. I'm glad everyone is following so far. Awesome. Okay, let's move on. What about row 2? So you see row 2 follows a slightly different general term, right? Okay. UN, we see UN, right? It's like our general term. Because I can plug in any number of n inside, and then I will get the term that it is, right? Okay, so for instance, if in this UN I plug in 2, right, then I'll get a different term, right? Okay, so for this, what will my U6 be? Okay, so U6 means that n is equal to 6, right? And I'm going to plug it into here, okay? So this is for row number 2, yeah? Okay, 20 minus 5, and then I'm going to put in my 6 over here, minus 1. It's actually 20 minus 5 times 5, right? Okay, which is 20 minus 25, and I get minus 5. So my U6 will be minus 5. And is this a finite or infinite sequence? Can you guys write in the chat, is it finite or is this infinite? So I have some finites, I have some infinites. Any more answers? All right, so most of you put infinite, okay? And that is the answer. It is infinite, okay? Or I guess some people pronounce it as infinite, but I pronounce it as infinite because it goes on forever. You see this dot, dot, dot? This dot, dot, dot over here represents that it will go on for some time, okay? Now let's do number 3, okay? Row number 3. Row number 3, we have 1 over 2 to the power of n minus 2. What will my U6 be? Okay, can you guys type in the chat, what will my U6 be? Gonna erase this so that we can do row number 3 together, right? So just take some time to calculate what will U6 be for row number 3. Okay, 1 over 16, thank you, Jindrat, okay. Kai Sing put 0.0625, okay. I'm not sure if that equals to 1 over 16 actually. Let me calculate. 1 divided by 16. Yes, 0.0625, 1 over 16. Okay, thank you so much for your participation, right? Okay, so let's work it out together. 1 over 2 to the power of 6 minus 2 will be 1 over 2 to the power of 4, which is, yes, indeed, right? 1 over 16. Good job. So we're going to put our 1 over 16 here. And is this finite or infinite? Again, we see over here that we have our dot, 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 right? It goes on forever. So we're going to write over here that it is infinite. I have a question. Okay, so U1 of sequence 2 is undefined, right? Yes. Okay, why? Because you see over here, we say that the sequence only exists from 2 onwards, from n equals to 2 onwards. So if I put here U1, it will not be included in the sequence. This is for sequence number 2. Okay, if I put U1, right, what will I get? Because I will get 20 minus 5, and then it will be 1 minus 1, right? 1 minus 1, this is 0. So ultimately, I'll get 20. But this is not included in sequence number 2 because over here I've defined that in this sequence, right, I only want it from n equals to 2 onwards. Does that answer your question, Ren? All right, awesome. I hope everyone understands. Okay, let's move on. Okay, so now we have our row number 4, right? Okay, where we have un is minus 1 to the power of n times n. Okay, and we have all the way from 0, right? Then 1, 2, 3, 4, all the way until 50. So of course, it ends at 50, right? Okay, it ends at a certain number. So this will be a finite sequence. And you can see, okay, I'm just going to erase this working over here. You can see that for U6, right, for my row 4, now we're at sequence number 4, U6 will be minus 1 to the power of 6 and then 6. Okay. Realize that minus 1 to the power of 6, right, because 6 is an even number, it will just become 1 times 6. So all I will get is 6. So that will be my answer. Okay. Realize that over here in the sequence, right, that they have defined is alternating. Do you see? It's alternating between negative and positive, right? It's 0, then -1, 2, -3, right? Why is it alternating? Because of this minus 1 to the power of n. This is an important lesson because sometimes, right, the question might ask you to define your own general term. So in your mind, you should know, if I have a minus 1 to the power of n, right, it will give me an alternating sequence, right? Let's see what it means, right? So for instance, if I put U7 for this sequence number 4, okay, it will be a negative number. Why? Because minus 1 to the power of 7, this is an odd number, right? And then I have a 7 at the back, okay? Because this is an odd number, right? It gives me minus 1 times 7, which will give me a 7 over here, which is why it becomes alternating. Okay, now let's do the very last row. We have row number 5. Okay, what will my U6 be? Okay, this one, I'm going to get you guys to calculate for me. What will my U6 be? It's going to take quite a while because you see, my UN is quite complicated over here, right? I'm just going to erase this last part. Okay, but please help me calculate what will my U6 be. I already have one answer so fast. Thank you so much. The answer they gave is 8. Okay. Any more answers, or do you guys agree with this answer? I only have 1 8 so far. Yes, okay, so you agree that it's 8, right? And yes, the answer is 8. So you just need to put this into your calculator, yeah? You just need to put 6, oops, sorry, into your calculator at the ends over here, right? And then you'll get 8. So for those of you that are interested, right, this sequence is known as the Fibonacci sequence, right? It is a very popular sequence in nature. So most of nature, right, like some spirals, they follow this Fibonacci sequence. It's very, very interesting. So you can go and look up on it. Is this a finite or infinite sequence? Come, let's see. Is it a finite or infinite sequence? Infinite. Very good. Infinite. Very good. Okay, yes. So everyone can agree, right? It is a infinite sequence. Why? Because we have our dot, dot, dot over here, meaning that it will go on forever. Awesome. Okay, so give yourselves a pat on the back, right? We have completed this first part, the first table over here. Okay, now let's move on. Just want to show you guys, right, that there's many different types of sequences. Okay, so we can say that a sequence is increasing, decreasing. Sometimes the sequence might be constant. That means all the terms, right, is that a constant, it's the same. Sometimes, right, our sequence actually approaches a unique value L, right? This L is known as the limit of the sequence as n approaches infinity, right? And then it is said to converge to this limit L. Okay, if it does not converge, okay, you can also say that it diverges. Let me just highlight it here. Okay, and in the next few screenshots, right, I have illustrated it for you. So over here we have, this is a constant sequence. Can you see? It always remains the same, right? It remains constant at a certain value. So no matter what I put into here, right, whether is it n equals to 1, n equals to 2, 3, 4, 5, I always get the same value. In this case, un will be equal to 2. Okay. We also have such sequences where you see over here, according to the plot, right, it is strictly increasing. Okay, and not just that, it is strictly increasing. You can see it is tending towards a certain value. That's why we say that it converges to L, where L is a certain limit, right? Okay, in this case, it will actually be converging to 1 over here. Okay, then we also have this plot, right? This sequence where it is increasing, right? But it's not increasing towards a certain value. In fact, it could go on forever and ever, right? Up here, we say that this is strictly increasing, but it diverges, right? It doesn't converge to a certain value. The next one you can see is going downwards, so it is strictly decreasing. Okay, again, it's strictly decreasing towards a certain value. So it is strictly decreasing and it converges to L. Okay, in this case, it's converging towards 0. Or it could be strictly decreasing and diverges. It doesn't converge towards a certain value. And then we have our special ones here, right? Where you see it alternates actually. We have a plot here, then here, here, then here, right? It alternates, okay? But in this case, you can see even though it's alternating, it actually converges towards the x-axis, right? It converges towards y equals to 0, right? It converges towards 0. Okay, versus over here, we have alternating as well, right? Dot here, 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 then here, right? Okay, it is alternating definitely. Okay, but it alternates and it diverges. It doesn't go towards a certain value. So in general, right, you can see right here the illustration on the different type of sequences that we have. Okay. So moving on from this, right? Okay, we're going to do example 1 now together. Okay. If everyone will take some time to read example 1 and try it out yourself. Okay. So I'm going to give you guys clues and then you're going to try the question yourself. I'll give you about 3 minutes to try out the example yourself. Okay. So the first 3 terms of a sequence are given by, okay, we have our U1 is 10, U2 is 6, and U3 is 5. Given that UN is a quadratic polynomial, so this is the clue I'm going to give you, right? What is a quadratic polynomial? It means that, okay, so UN is a quadratic polynomial. It means that UN follows the general formula of what? AN squared plus BN plus C, where your A, B, and C are actually constants, right? So this is the major clue that the question gives you, okay? So given that UN is a quadratic polynomial in N, that's why this is in terms of N over here. Find UN in terms of N. So I'm going to give you guys, okay, a couple of minutes to try this out yourself, and then I will go through the question. Okay, if you have any questions, feel free to put it in the chat. Okay, I'm going to give you guys 1 more minute. to try out the question? Okay, I hope you guys have maybe tried the question, right? Okay, because big part of learning is trying it yourself. Okay, now I'm going to go through the question. Give me a minute to set everything up. This is not, there's no space. Give me a moment. Okay, it should be fine. Yeah, okay, so example 1. How are we gonna do this? Okay, that the question, right? Okay, will always give you like clues, right? And they won't give you clues for nothing one. So whatever it is, right? Just write out like the clues that the question give you first. So for instance, the quadratic polynomial one, right? First, you're gonna write, okay, you're going to let un be your an square plus bn plus c. Okay, and what does this mean? The first clue that they give you is u1 is equal to 10. So if u1 is equal to 10, and I plug it into here, right? Okay, into my general formula, what do I actually get? I get that 10 is equal to a plus b plus c. Can you see? So this is my first equation. Now I'm going to use my second clue. They tell me u2 is equal to 6. So u2 is equal to 6. If I plug it in, what do I get? I get a 2 squared, so that's 4a plus 2n plus c. And this is my second equation. And then finally, my last one is my u3, right? The last clue they give me, u3 is 5, which if I plug in, right, okay, n equals to 3, right, I will get 9a plus 3n, 3b plus c. Sorry, this should be a b. And this is my third equation. So now I have 3 equations and I have 3 unknowns, right? So it's very easy for me to solve this question now. I can just use my calculator, right? Or you can do the simultaneous equation. You can write, right? Okay, using GC. Okay, using your graphing calculator or whatever calculator, right? Just put the 3 simultaneous equations into your calculator. You will find, okay, that what? Can someone tell me what will your A be, your B be, and your C be? And from there, therefore, what will your UN be, right? Okay, depends on what your A, B, and C are. Okay, so put this into your calculator and tell me yes. Okay, good job. A will be 1.5. B will be negative 8.5. And C will be your 17. Good job. Okay, so that means that your UN will be 1.5n squared minus 8.5n plus 17. Can you solve this without a graphing calculator? Oh, yes. You can. You can even put it, right, in your normal like calculator, the gray color one, right, that you guys have from secondary school. Under like, I think setup or menu or something like that. Then you have equations. Yeah, and then you have like, there's one selection for like 3 simultaneous equations, or you can just like manually do the simultaneous equations on your own. Yeah. Okay, let's move on to part 2, right? Find the set of values of n, okay, for which un is greater than 100. Again, just use the clue in the question, right? Okay, they tell me that un is greater than 100. And I know that my un now, right, okay, follows this general formula. So I'm going to plug that in. I'm using part 1, okay? So that means that my 1.5n squared minus 8.5n plus 17, right, has to be more than 100. Okay? For this to be more than 100, I can also, right, bring it over, and I'm going to put here 1.5n squared minus 8.5n plus 17. I'm going to minus off the 100, so I can just say that this has to be more than 0. Okay, either way, it is fine. Okay, so why do I want to do this? So that I can put this into my GC, right? And when you put it into your GC, you will get this, okay, over here, this graph, okay? And you will see that for it to be more than 100 means it has to be above the x-axis, right? So this is one of the points, right? It has to be greater than 0, right? My x, okay, at this point is actually 10.8, okay, or rather 10.79. So from the GC, you can say that, okay, your n has to be more than 10.79. Okay, in other words, right, what will the solution set be? Solution set, you have to write like that. You have to have a curly bracket. So because your n has to be a positive integer, z represents, okay, integer. Okay, the plus at the top represents positive, okay? But n has to be more than or equal to 11. Okay, why does n have to be a positive integer? Because you see over here, what is n? N is actually what I sub into here, right? I cannot have u 5.5, for instance. It needs to be an integer, a whole number, which is why I put here n has to be a integer, a positive integer. Okay, and it has to be more than 10.79, but the closest integer will be 11. So I put here n has to be more than or equal to 11. And that's all for example number 1. So this is a real A-level question. It came out in 2009, so quite far away, right? Like quite long ago. Yeah, so you should be proud of yourself if you managed to solve this question with me. Okay, let's move on. Oh, okay. So what we've been talking about so far is sequences. Now, right, let's turn our attention to what a series is. Okay, and you can see over here, a series is actually what? A sum, okay, of the terms of the sequence. So for instance, just now our sequence, maybe we have U1, U2, all the way until UN, right? Okay, but the series, okay, this series over here, it will be the sum of the terms inside the sequence. So it will be U1 plus U2 plus so on. Okay, sorry, I just got a question. Why can't it be more than and equal to 10.79? Okay, it cannot be equal to 10.79 because my n, right, is an integer. It's a whole number, which is why it cannot be equal to 10.79. It can only be more than 10.79. Why does my n have to be an integer? Because I'm going to sub it into here, right? It's always going to be U1, U2, U3, right? I never ever have a decimal here. I never ever have a U5.5. Does that answer your question? Okay, I have another question coming in. Why must n be positive? Okay, because we always start from the first term. Okay, can n be 0? Yes, only if the question defines it. If not, right, the basic assumption that you will make is that it always starts from the first term, which is why we always start from U1. Only if the question states that I have U0, for instance, right? Okay, then you can go and find whatever it is. Okay, will there be a U -1? No. Because in the sequence, when we say n is 1, it really means that it's the very first term of the sequence. There shouldn't be anything before that. That's why n cannot be negative. Does that answer your question as well? Okay, I have another question. How do you key it into the GC? That's very interesting. A very interesting question. Okay. How basically, okay, give me 1 second. Oh, I'm gonna admit someone in. Okay, 1 second, I get my GC for you. Okay. Okay. So my GC is the super old one. It's super thick, as you can see. Your GCs will be much thinner than this, okay? So what you're gonna do is, you're gonna on your GC, it looks something like that, right? So now I have a blank page, okay? You're going to press, right, the top left button, okay? Over here, it says y equals 2, okay? And you should go to get to this page, okay? Then you're gonna key in. So for this case, okay, I wanna key in 1.5n squared minus 8.5n plus 17 minus 100. Okay, so I'll put 1.5 first. You can see here 1.5. Instead of n, I'm going to use x because that is the general term that we use for this like graphing calculator, right? You can press the x here. It's next to the green alpha button, okay? X. And you should see an x here. Then I'm going to put square, okay? So for the square, I'm going to press the arrow up sign to indicate power of 2. Okay, so I have my 1.5 x squared. And then I key in the rest as per normal, right? So minus 8.5. And then again, I put x plus 17 minus, minus 100. So you should get this at the end of the day. Let me pin. Oh, sorry. No, let me do this instead. Side-by-side gallery. Spotlight for everyone. Yeah, okay. Now you can see. Okay, so this is what you'll key into your GC. And then to get the graph, you are going to press all the way at the right-hand side, right? The most right button at the top, the graph. And then you'll see that it will plot for you. I think most of you would have not gotten your GCs yet. But yeah, okay, so plot finished already, right? Then you're supposed to find out what is this value, the one at the x-axis, right? Correct? So what you're going to do is you're going to go press your blue button, second, and then calculate. So that is the second right top button, right? Okay, under trace also, press this. Then you're going to press the second one. So you want 0, so number 2. And then you're going to trace, right? Okay. Give me a second. Okay, I'm gonna trace it to around there. Okay, so this is the one I want. Okay, I'm gonna press enter. And then I'm gonna go to the other side and press enter, enter again. And they'll tell me, you see over here, that I have 10.79. Is everyone good? No, this part is like a bit dry, but yeah. Okay, awesome. I hope that was helpful for you. Okay, let me off my GC now, and then let's continue with the lesson, okay? But thank you for all the questions. Oh, how do you get the value without GC? Okay, unfortunately, I don't think you cannot. Yeah, you can probably like let this 1.5 n squared minus 8.5 n plus 17 minus 100. You can solve it like how you would any other quadratic equation. Then you probably have to use your x equals to minus b plus or minus square root of, right? So you treat this as like a quadratic equation. Okay, and then you find the values of n. There will be two values of n. One is negative, one is positive. You take the positive one. Yeah, and you probably have to use the general formula of like x equals to minus b plus minus square root of this one, right? Okay. But the benefit of you being in JC is to get to use the graphic calculator. So don't do this method, okay? It's like a bit waste time. Please go and get your GCs, okay? And use your GC to your benefit. Use it to solve the question. You'll find that throughout like our lessons and throughout, I guess, your H2 math, right? It's like you always come across this phrase using GC, right? So you're always going to be using your GC to solve the question. Yeah. But yeah, you can solve it without the GC, but I think it's just much, much slower. And in the exam, like you want to save as much time as possible. Does that answer your question? Okay, let's move on, okay? But thank you for all the questions, okay? So back to what a series is. Basically, a series is what? The sum of all the terms in the sequence, correct? Okay, and again, a series can have finite or infinite number of terms depending on what the sequence is, okay? Two very important formulas for you to remember over here. So all this is not given in the formula sheet. In JC, you are given a formula sheet called the MF26 in the exam, okay? This is not given in that formula sheet, meaning that you have to remember it, okay? So you have to remember that UN, you can find UN by doing Sn minus Sn minus 1, okay? S denotes actually the series. So the series, for instance, maybe S10 minus S9 will actually give you UN, for instance. Actually, in this case, it will specifically be U10, okay? And then the other formula you have to remember is this. U1 is equal to S1. Of course, right? Because if S1 is the sum of the sequences up to the first term, then it will actually just be the first term. Okay? Okay, so I do want to illustrate this for you. I'm not going to do until 10, right? But let's do a simpler version. Let's say, right, my sequence is my odd numbers. So I have, this is my sequence, right? I have 1, 2, sorry. Try again. 1, 3, 5, 7, 9. Okay, let's say this is my sequence. Right, it's just an ordered list. Okay. My U4 will be 1 plus 3 plus 5 plus 7, which if you go and calculate will be 16. Okay. My U3 will be 1 plus 3 plus 5, which will be 9. Okay. You can also do a direct comparison of these two over here. Then it's very clear, right? You can see that from here, right? Okay. Let's use another color. Okay. If I take, right, U4, sorry, this should be S, because it's a series. Don't want to confuse you guys. It should be a S, sum of 4. Okay. So if I take my S4 minus my S3, in other words, I take 16 minus 9, I get 7, right? And you realize that this is equal to U4. So that is what this first formula is saying. Okay, you can see also, if you take this, right, minus of this, you are actually what? Cancelling out, right? Minus of, minus of, minus of, you'll only be left with the last term over here. So that is what this rule is saying. Okay, is everyone good? If you're good so far, please give me a thumbs up. All right. All right, okay, awesome. Let's move on. So now that we have laid the foundation, right, we know what a series is, we know what a sequence is, okay? We are going to deep dive into arithmetic progressions. An arithmetic progression is a sequence, okay? It's a sequence of numbers for which the difference, okay, for which the difference between every two consecutive number is a constant. Okay, that means that when I go from the first term to the second term, maybe I'm minus 2. Then from the second to the third term, I will also minus 2. So the difference is always the same between the terms, right? Or it could be I plus also, right? It could be from first term to second term, I plus 1. Then second to third term, I plus 1 again. Okay, that's also known as a arithmetic progression. Okay, so this difference, right? Okay, this constant difference is also known as the, common difference, and we denote it by D. And how do you find this D? You take the difference between the two numbers, lor. Okay, so I'm going to illustrate example. Just now, this is actually an arithmetic progression, right? Because I have 1, 3, 5, 7, 9. I always plus 2, plus 2, plus 2, plus 2. So for this, it's very clear, right? What is my D? My common difference will be 2, because I'm always adding a 2, right? And how do you find that? You can actually find it by taking, for instance, 9 minus 7. Okay. How do you find the nth term of an arithmetic progression? So through years of like formulation and testing, right? Okay, like not really years, but like, yeah. Basically, mathematicians have come to the conclusion that for arithmetic progressions, this very specific type of progression, right? You can find the nth term with this general formula. So they already write out the general formula for you, and that is in this box over here, right? Where un is equal to a plus n minus 1d. Let's break this down. Okay, un, of course, is the term itself, right? N is like the number of the term. A is your first term, the very first term. Okay. Your n is the number, right? The number. And then your d is your common difference. So you can find any term in the arithmetic progression, right? Okay. By using this general formula. You need to memorize this again. It's not given in your formula sheet. Yeah, okay. So, for instance, let's look again at this example, our arithmetic progression, okay, or AP, as we also know, okay. This is my first term, right? Okay. This is my second term. Okay, so in other words, sorry, let me backtrack. This is my U1, U2, U3, U4, U5. So my first term is 1, right? This is also my A in this formula over here, right? Okay. So how do I find, for instance, I want to find U6. We all know that it's going to be 11, right? Because 9 plus 2 is 11. But how do I find my U6 from this formula? Sorry. I'll plug in, okay? So my A, my first term is 1. So I'm going to put 1 here. Plus, and then I have my N, right? In this case, my N is 6, right? So that's what I'm going to put in. 6 minus 1 times D, which is 2, your common difference. 1 plus 5 times 2, 1 plus 10, which is 11. Okay, so I hope that you guys understand what this means, okay? If you understand, can you find for me, right, for this AP, right, what will U20 be? And type it into the chat. What will U20 be for this arithmetic progression? So very quickly, just calculate for me, okay? I will also be calculating now with you. What will U20 be? Thank you so much. Okay, we have our first answer. Okay, yes, thank you so much. Okay, awesome. Okay, so most of you are putting in 39, okay, which is correct. Good job, which means that you fully understand this concept. Okay, let's move on. So some examples of the arithmetic progressions here. Okay, let's fill in. I'll do the first row with you. Okay, for the first row, what's our first term? Super obvious, right? It's just 3. Okay, the common difference, so it's going to be a plus 2 again, right? Again, we have our odd numbers over here, so our common difference is 2. So our formula for UN in general will be what? I have my 3 plus n minus 1, 2. You can choose to expand and simplify this, okay? It will be 3 plus 2n minus 2, which is 2n plus 1. So you can also choose to expand and simplify it like this. Okay? Can someone tell me, right? Okay, so obviously for the second row, this second arithmetic progression, right? Okay, my first term, so obvious. You just look at the first term, it's just 20. My common difference, okay, again, I'm actually doing what? Minus 5 minus 5. So my common difference will be minus 5. Okay, and then my formula will be UN equals to A, which is 20, plus n minus 1 times my common difference, which is minus 5. Again, I can expand out, right? 20 minus 5n plus 5, 25 minus 5n will be my formula for UN. Okay. Moving on to the last row, okay, obviously the first term super easy, right? Okay, it's just 3 over 2. Okay, can someone tell me what my common difference is? Very good. Okay, we have 0.5, in other words, half. Okay, thank you so much. Okay, what will the formula for this UN be? So again, we're going to plug in, right? It will be UN is equal to my first term, 3 over 2 plus n minus 1, and then your D will be half. So again, it will be 3 over 2 plus, you can expand out to be half n minus half, which will just be half n plus 1. And that is your final answer. Okay. So all these are examples, good examples of arithmetic progressions, okay, or arithmetic sequences, right? Of course, then what is an arithmetic series? It is a series, okay, when all the terms of the arithmetic progression are added together. For example, for the first AP, right, 3, 5, 7, 9, 11, it is only an arithmetic series if it is 3 plus 5 plus 7 plus 9 plus 11, so on and so forth. Okay. So we're going to go down now to the next page, okay, where we talk about arithmetic series, okay, the sum, okay. And in general, okay, you can read this on your own, right? It's just sort of like showing you, right, like sort of proving to you how we get the formula. You don't need to know the proving at A levels. You just need to know this is the formula. Again, it's not given in your formula sheet, so you have to memorize this along with the two formulas that we just went through. Okay, so for the sum, right, okay, of that arithmetic series, we can see it as this general formula. There's actually two if you can see properly here. Okay, the first one says that the sum of my arithmetic progression will be n over 2 times 2a plus n minus 1 times d. The second one is actually saying it will be n over 2 times u1, okay, the first term, plus the term that I am ending with in this progression. Okay, so let's see what we mean here. Okay, maybe we do an example again. Going back to our previous example, right? Okay, we have our 1, 3, 5, 7, 9, so on and so forth. Okay, this is my U1, U2, U3, U4, and U5, right? Okay, let's say I want to find my S5, which will be 1 plus 3 plus 5 plus 7 plus 9, but I don't want to do it manually. I will just plug it into this formula. My n is 5, right? So I'll put 5 over 2, big bracket, 2 times of the first term, which in this case is 1, plus, and then again, my n will be 5 minus 1. My d is, just now we already established it's 2, right? The common difference. And then you can calculate out what the sum will be. So can someone calculate this out for me, right? What will the sum of this be? Thank you so much, Junie. And thank you, Adnan. Okay. Yes, it will be 25. Okay. Let's see how it goes with the other formula, the second formula. Let's say I want to find U4. Sorry, S4. I will just do n, right, which is 4 over 2 times my U1 is 1 plus, and then my U4, because I want S4, okay, will be 7. Okay, in other words, it will be 2 times 8, which is 16. All right. Okay, so that is how you use this formula. Again, please go and memorize this, right? It is not given in your formula sheet. Okay, so let's take a look at example 2. Find the number of terms in the arithmetic progression, okay, and the sum of all the terms. Again, I'm going to give you guys 3 minutes, right, to apply what you've learned and try out this example. Okay, So just 3 minutes. Take some time and maybe take out a full scap, or if you printed it, do it on the paper, right? Try out this question. Okay, 3 minutes have passed. Okay? Some of you have sent me your answers already, and I'm so excited, right? That you guys are trying it out. Okay. So those of you that have sent me your answer is correct. Good job. Okay. For those of you that I guess haven't tried it yet, maybe not comfortable with trying yet, right? Yeah, let me go through the question with you. Okay. So find the number of terms in the arithmetic progression. Okay, sorry. For those of you that got it right? Feel free to go to the next example, example 3, okay, and try it out yourself. Okay, so I'm gonna stay on this page for a while, so maybe you can screenshot it so you can try example 3 while I'm going through example 2 with the rest. Okay? Okay. Example 2. Find the number of terms in the arithmetic progression 20, 15, 10, so on and so forth, and the sum of all the terms. So the first term is obviously 20, right? This is my A, right? Okay. My common difference. So whenever I do a APGP question, right? Okay, arithmetic progression question, I always try and identify all my terms first. So like my A, my D, right? What is the N that they're looking for, etc. Okay. So my common difference is actually -5. Okay, so first term is A, common difference is -5. Number of terms, I'm not sure, right, from this. So I'm just going to denote it as N. Okay, so I want to find now what my N is. What is my UN? Okay, what is N? And I know that, okay, n has the general formula, un has the general formula 20 plus n minus 1 times -5. And I know that my last term is actually -135. So this is equal to this. I'm going to solve this. Okay, in other words, right? 20 minus 5n plus 5 is equal to -135. And my n, if I go and calculate out, will actually be 32. So, okay, I know that this is my new 32, my 32nd term. And now I need to find the sum of all the terms. In other words, what? I have total of 32 terms here. I want to find my S32. So I'm going to use this general formula, okay, where I have 32 over 2, right? I'm going to use the second one. It seems a bit easier for me in this case, where I take the first term plus the nth term, so the 32nd term in this case, so it will be 20, okay, plus -135. If you go and calculate this out, you should get -1840, which will be your final answer. Okay, so if you got this right, give yourself a pat on the back. Good job. And let's move on to example number 3. Example number 3 is a super common question in A-levels. Okay, so if you can get this right, that would be fantastic. Okay, no pressure, of course. Yes, so take some time. Again, I'm going to give you another 2 to 3 minutes just to try out example 3. Feel free to send me your answers, right? And if you have any questions also while you're doing it, feel free to ask me as well. Okay, so someone asked me, is D equals to, okay, maybe I should answer this privately, right? So that you guys can try it out yourself, but okay. Okay, I'm going to leave you guys some time to try it out. Okay, does anyone have an answer for the first part? So in an arithmetic progression, the 8th term is twice the 4th term and the 20th term is 40. Okay, let's break this down first. Okay, the 8th term is twice the 4th term. So 8th term is, U8, it is 2 times of U4. Okay, and we know that U20 is 40. Find the common difference. So they want you to find D and the sum of the terms from the 8th to the 20th inclusive. Okay, thank you for the answers. Okay, let me just privately reply each of you, right, as to whether your answer is correct. Okay. Again, if you got this question correct, okay, feel free to start trying example number 4. Okay, I will leave it here for a while. If you, let's say, don't have it, you can screenshot it first so that you can try it out while I explain the rest. Okay, so going back to example number 3, okay, we let the first term be A and the common difference be D again. Okay, I'm going to write out the 2 clues. Okay, so I have U8 is 2 times of U4. Okay, in other words, if I write everything out, it will be what? A plus n minus 1. So 8 minus 1 is 7. 7 times of D is equal to 2 times of A plus and then 4 minus 1, which will be 3, D. So I'm using this general formula that we learned just now, right? Where UN is actually A plus n minus 1D. So that's how I got this, okay? So this is my first clue, and I'm going to expand this, right? Okay. A plus 7D is 2A plus 3D, okay? A is 4D. Oh, sorry. Careless mistake. Wait now. This should be 6D. In other words, you should get that your A is equal to D. So this is what you get from the first clue. The second clue tells you that U20 is 40. Okay. If U20 is 40, and I have my U20 will be what? A plus 20 minus 1 is 19. 19D is 40. And I know here I have my first formula, right? This is formula number 1. Formula number 2. I'm going to sub formula number 1 into number 2 to find out what my D is. In other words, right? D plus 19D is 40. 20D is 40. And D is actually equal to 2. So that is the first part of my question answered. I found my common difference. Okay. Second part, now I need to find the sum of the terms from the 8th to the 20th inclusive. Okay. What does this mean? Let's look at this from a number line perspective. Okay. I have my number line. I have my first term here. My 8th term is probably somewhere here. And then I have my 20th term here. Probably number 7 is somewhere here. I want from my 8th to my 20th term, including the 2, right? But when I find, for instance, my S20, I'm actually finding, right? Okay, again, I'm going to draw here. S20, right? Okay, is from my first term all the way until my 20th term. So how? So actually you realize, okay, this is a technique that you need to learn. Okay, this is S20, yeah, okay. You need to realize that you need to take this S20 minus of S7. I need to minus off from the first term to the 7th term. When I minus this off, I will be left with my S8 to my S20. Sorry, my U8 to my U20. Okay. So In other words, I need to do S20 minus S7, which will be, okay, I again use this general formula that I just learned, right? Okay. It will be for S20, 20 over 2, 2, and then my A is actually 2, right? Okay. Plus 20 minus 1, and then D. Okay. I will take this, I will minus off my S7, which will be 7 over 2. 2, again 2 plus 7 minus 1 D. Okay. So if I go and calculate this out, right, okay, I should get 420 minus of 56. Yes. So it'll be 420 minus 56, which is 364. And this will be your final answer. Okay. So we're not going to do this alternate method, right? Because I think it's a bit confusing. Okay. But this is how you solve example number 3. Someone is asking me, why is it S20 minus S7 instead of S20 minus S8? Okay, let's read the question again, right? I want the sum of the terms from the 8th to the 20th inclusive. That means I want my 8th term in the sum. Okay, what does this mean? If I take my S8, what is S8? S8 will be from first term to my 8th term. It will include my 8th term. This will be my S8. So if I take S20, 1 all the way to 20, right? Minus of S8, can you see I'm actually minusing off the 8th term also? But I want to include my 8th term, which is why I just do from 1st to 7th term, I find S7. And I minus off from S20. Does that answer your question? Okay. Sorry, let me check first. Okay, so I have another question. Can you repeat again the first part of example 3? Okay, this first part. What you're really doing is just using the clues that they give you to find your A and D. Okay, they tell you that the 8th term is twice the 4th term. So this is what it means, right? U8 is actually 2 times of U4. You're going to write out in terms of the general formula because you want to find your A and D. After you write out in terms of your general formula over here, you can simplify to get your first equation, which is that A is actually equal to D. Okay, then you use the second clue they give you that U20 is 40 again, plug in the general formula that A plus 19D from here, right? A plus 19D is 40. Then you will simultaneous equations these two equations to finally find that D is 2. Is that clear for you? Okay, if everyone is clear, do give me a thumbs up. Okay. Awesome. Please don't feel shy to ask questions, okay? I'm here to answer your questions. Okay. Now, let's move on, right? Okay, to example number 4. Some of you may have started trying example number 4 already. Okay, I'm going to, again, give you just 2 minutes, right, to attempt the question. Okay, I do want to leave 10 to 15 minutes of the lesson for any questions that you might have, right? Also for me to get feedback from you guys. So we'll see how it goes. But in the meantime, do try and do example 4. Yeah. If you have any like questions, you can also stay back after the lesson. I will try and answer your questions, but I have another lesson at 3. So we'll see how it goes, okay? That's why I want to give that buffer time of 10 to 15 minutes. But yeah, okay, come. Try example 4. Oh, okay. What graphing calculator are you guys supposed to buy? Not this, not the thick and heavy one. Your school will actually mass order with you guys. So they will probably ask you guys to order from with them lah, and then mass purchase, right? Yeah, so you just wait for your school. They will ask you to buy the correct graphing calculator. Just buy together with your school. Does the GC contain all the functions of the normal one we use in secondary school? It contains all the functions and more. Yeah, it is a very powerful calculator. So everything that you can do on your normal calculator, right, you can do it on your GC also. But usually I encourage my students to bring both into the exam, the normal one and the graphing calculator, because sometimes the graphing calculator is a bit, honestly, it is harder for you to compute things like normal calculations, right? I encourage you to use your, like all these normal calculations, just use your normal calculator will do. It is not possible to not use the GC at all, because you have all the graphing calculations and stuff, right? You need to use your GC, you need to have it, okay? It is quite expensive, I understand, but it is a necessary for H2 math. So if any of you guys have tried example 4 and want to share with me your answers to check, right, feel free to put it in the chat, and I will reply you guys either individually, or if you don't mind, I can just reply you, on the chat itself as well. Great job, everyone. I've received quite a number of responses already, and most of you are correct. So I'm super happy about that, okay? I'm just gonna leave, right, this form, okay, in the chat, okay? This is a feedback form, but also, right, a form for you to sign up for the actual group tuition class starting next week, okay? So if you have any, I guess, friends that maybe you want to join with, feel free to fill in the form send them the form as well. Yeah, so excited to see most of you, I guess, I hope you guys join the class. It'll be sort of like this, right? But maybe a bit more intense. Maybe I'll try and go a bit faster. I think because you guys are still J1, very, very new to the JC system, right? I don't want to scare you guys and be like, oh, we have so many things to cover, blah, blah, blah. Just trying to take it one step at a time for now. Yeah. So if you sign up, right, I will take it as you are interested and I'll follow up with you via like WhatsApp or like, I guess, email, whatever it is, right? The contact that you leave me with. I won't take it as, you are 100%, going to join. It's more of like an interest form. And then I will definitely follow up with you after that. Yeah. Understand you guys, most of you guys would have to ask your parents as well. But yeah, this is really just number one, a feedback form. Number two, for you to indicate your interest as to whether or not you want to join the lesson, and I will follow up with you guys. Okay, so let's go through example 4. Since most of you have completed it already, right? This will be the last example that we go through today before we end the lesson, okay? So an arithmetic progression whose first term is 2. So immediately, good habit for you to write, right? That this is A, okay? And whose nth term is 32. So this is UN, has the sum of its first n terms equal to 357. So this is your Sn, okay? And we're supposed to find n, okay? So again, our A is 2, our common difference, we're not sure, right? We just put it as D, okay? I will use all the clues in the question, okay? So I will start with my Sn, which is 357, right? Okay, from the question. And this is equal to n over 2, right? 2, okay, my first term is 2, plus my last term, which is, as we know, 32. Okay, from here, I'm going to find my n, and you can find out that n is actually 21. I think most of you will have, been able to find this, okay? And, okay, the next one, okay, they say, if the kth term has a value exceeding 100, find the least value of k. Okay, the kth term has a value exceeding 100. In other words, UK is more than 100. So in order for me to do this, I need to define UK, right? For me to define UK, I need the common difference. So I'm going to use the other clue in the question that UN is 32, okay? So U, and I know that N is now 21, right? U21 is 32, which is my A, so my 2, plus n minus 1, so 20, D. From here, I will find out that my D is actually 3 over 2. So with that, I found my A, found my D, I've found almost everything really, right? I can easily solve the question. What will UK be? Okay, UK is a general term. It will be A again, plus, okay, n minus 1. In this case, my n is K. K minus 1 times my D over here, and this has to be more than 100. Okay, I will compute, right? So I'll do K minus 1, 3 over 2 has to be more than 98. K minus 1 has to be more than 196 over 3. K has to be more than 66 and 1/3. In other words, the least value of K, because again, it cannot be a decimal. The least value of K will be, it has to be more than 66 1/3, it has to be 67. Okay, and with that, we have come to the end of our lesson, right? Okay, we have gone through quite a bit today of arithmetic progressions at least, okay? We will be finishing up the next lesson, okay, with the remaining examples, and then we'll even be proceeding on to geometric progression. Okay, I'm gonna leave this 10 or 15 minutes for you guys to ask me any questions. Okay, please fill in the form, okay, if you are interested, and if you have any feedback from me, I'm always excited to hear some feedback. Okay, yeah, and thank you so much for attending today's trial lesson. I hope you enjoyed yourself. That's all. If there's nothing else, you guys can slowly leave the chat. I will probably leave when there's like a few people left in the room. Okay, so thanks everybody and goodbye. Thank you. Remember, you can ask me any questions, okay? Thank you so much. Okay, I do have a question. Why is it 2 plus 32? We are using, okay, the formula over here, dear. This formula, the second formula. So 2, right, is my first term. 32 is my n. Does that answer your question, Junie? Okay, I'm going to flashback this example. Thank you so much, everyone. Thank you. Thank you. Bye.